Okay, we don't need to type it now, but do you have something typed? Somewhere, do you have something typed and saved on your computer?
No.
Okay. Then it doesn't matter. You can't paste it in.
Yeah. I
Okay, that looks
can't.
better. Yeah, you can't paste in. I need to get a minute and just rewrite this thing using Grok. Um and I'm not sure how exactly I'll do all that, but I may need to just take a brief sabbatical. Um all right, Roy, we're going to do a computer today, which is fine. Um as you're typing it, just I don't know what you're doing. It doesn't really matter. Why we like goodbye songs. Um Hey! Okay, as you're typing, watch this, Roy. I click save and it says saved. Or I do Control S and it says saved. Watch for the green light. If you don't see it, something's wrong. If you click save and it's that stupid long line of garbage, then just wait a few seconds. Okay? If you click save and you see nothing, then you need to do this. Right click and open in a new tab and then log in again. Okay? And then log in there, close that tab, go back, and then try to save again. All right? Does that make sense?
Yes.
Okay, I think what I need to do is I need to work out a system where it saves it in the browser. Okay. Um Also, before you submit it, make sure you save it before you submit it. But before you submit it, just copy the whole thing anyway. And, save it on your computer just to be safe. I'm sorry that that's the way to do things. But this is a great little website that I made, but it just needs more time to develop. Last time I developed it was 2021. I mean, it's been 5 years since I developed, and I had more that I wanted to do with it. I just couldn't get it done. All right. Okay. Let's do something. Let's finish up Linux 201 and get on to 301. 301's a lot more fun. So this is about the file system hierarchy standard. Okay. Wow. Let's get rid of that. This is the file system hierarchy standard, the FHS. We have, if I do this, that's so much better. Hey, shut up. Hey, I don't want drama. I don't want cheap drama anyway. I canceled Disney. Huh. All right. Well, let's just do this. Okay, so if I go here, this will, hey, shut up. This will show us for example, I can go to well, that's interesting. I can't go to root. I don't see the computer here. Windows, Kali, and Arch, but I don't see the main computer. I can just type it up in here because Linux is awesome because they know that I'm going to want to hack the command line and just go in. There we go. So if we go in here, we're just looking at the root folder. And you can see that we've got the same stuff. Bin, boot, desktop, whatever that is. Oh, file system packages. Desktop file system packages. What's in there? Huh. Jake, I love you. Go lay down. Go to sleep. Just lay down, buddy. Lay down. These are the basic file, the folders that you find on the root of the Linux system. Let's put this in a nice little list here. ls-1. And we get this nice little single column thing. There we are. So we have bin, boot, dev. Oh, that's for devices. Like your mouse might be in there. And remember, in Linux, everything is a file. So this is my mouse I'm using right here. It's old and worn out. I think it goes back to my time in Taiwan. And by the way, I might be going back to Taiwan. Taiwan is chasing me down. Taiwan is chasing me down, so who knows? Life may pull me back there. Okay. Home, lib, lost and found. Home is where your stuff is. So that's like where my personal files are. www can be the web user. I don't know why the web user needs a home in the home folder. Usually that's in the serve folder or the variable folder. But like this is my home folder with all my junk. You know, when I first open up this file manager, I get this. Well, hello. Well, hello. I love you too. Yes, I love you too. Okay, now, thank you. Yes, thank you. Okay, all right. Okay, I need you to get down. I'm busy. I'm busy. Thank you. Okay, all right. Okay. This is Blake. He likes to get into videos. So, you know, that's your home. You know, JC is the user, which is that JC there is this JC right here. It's the same thing. Okay. So we go back here. That's home. Okay. That's where you put your junk. That's where you put your stuff. For like, it's your home. That's your space. Those are your files. You can do stuff with them. You can work with them. Usually, the stuff that you work on when you log into the computer will be in your home. Okay. So the web user, there's a user that manages your websites. So for example, this this Pinkwright website here that just has all kinds of trouble because I need to develop it better. This is a PHP program sitting in a folder someplace on a computer someplace in San Francisco. And on that computer, it's the same setup as this. You go into serve and then www and then HTML and then it'll be there. Okay. You know, and I put it in serve. Jake, it's okay, buddy. I love you. Did you hear him cry? Oh. Okay. So he thinks I'm talking to somebody and he wants me to talk to him. Okay. So let's go back here. All right. So just get a good look at these. Here are some, you know, we're going to look at some, but your stuff needs to be in, you know, Linux stuff goes in these folders. And if you're going to use Linux, you want to know about it. They belong in certain folders. Jake, I'm sorry, buddy, but you got to lay down. Just lay down. Don't worry about it. Just lay down. Just lay down. It's okay. You'll be okay. It's okay. Just lay down. It's okay. It's okay. So there we go. In Linux, everything is a file. Voila. And so your mouse will be in devices. Let's go look in devices. G space DEV. Let's just look around. Look at that. NVMe, all these are these NVMe things. Those are my high speed drives. TTY, those are internet connections. Disk, fuse. Oh, IC. These are my processors. I've got like 16 cores on my i7 processor. These are video. Video 1, video 2. Yeah, I've got videos. My mouse is probably one of these. Anyhow, here's the thing. Random is just a bunch of random numbers. Watch this. Cat random. See that? It's just constantly random is constantly creating random numbers. Random ones and zeros. And so if I want to copy a nonsense file, then just a file full of nonsense that doesn't mean anything at all, I can copy part of random, and it will just keep producing new, you know, it just never stops. Zero produces zeros. Well, let's see what that does. Let's see what we get there. There you have it. See? We get 0 from it. Isn't that great? There's another one in here called null. Null. Okay. Null is in fact, like if you want to delete everything on a disk, you're supposed to write over it and then delete it again and write over it and delete it again to make sure everything's gone. You could use urandom to do that. Copy urandom to the disk and make it like, you know, 2 terabytes or whatever. Delete it all, copy it again, delete it all, and just keep writing nonsense to the disk. You can use urandom for that. Urandom is not an actual thing. All these orange things, they're like devices, kind of. Like this is constant random ones and zeros. but it looks like a file. Jake, you gotta chill out, buddy. I can't keep running in there. No, there was a little dog who cried help. And the villagers came and there was nothing there. And so then he didn't come back. No, Jake, I'm sorry. Okay. He's just sure that he's missing out on a great conversation. Okay. So these, all of these orange things are really devices. But I can interact with it here in the file system. I can see it. Let's see. I wonder if I can get times on it. Look at that. 5:44 is our time. Okay, so 5:44 was boot up. That's when I turned the computer on. So all these were last created, you know, when I turn the computer on. When you turn the computer off, they all disappear. You cannot see them on the disk. It looks like a file as long as the computer's running. Let's go up a directory. That's devices. And you'll see a lot of these virtual files like this. It's a device that you can look at like a file. Like, for example, here, if I go up here, this is my volume level right here. Okay. Somewhere there's a file that has this. Somewhere there's a file that has this number from 1 to 100. And if I go in here and I edit that file and I change the number, then this will jump up. And when I go like this, that file's number changes. In Linux, the way Linux works, everything is a file. Like you can hack into someone else's computer and you can edit the file with the volume through the text typing and play with his volume level, and it jumps up and down and he doesn't know what the heck is going on. Okay. Windows, you could probably do that. It'd probably be a command. You know, you can still do everything through the command line. Everything can be done through the command line. Everything. It could be complicated. Jake, lay down, buddy. But part of how you want Linux to work, everything's a file. So if you need to, you can fall back here, and if you know enough, you can go do stuff. That's how Linux works. Everything in Linux is a file. Let's go look at what's in the proc directory. Proc. We go in here. Okay. All right. So what? Okay, we'll... Okay, all right. I think, let's go into... All right. PROC is for process. And a lot of these are settings. Like one of them is limits. Jake, you gotta lay down, buddy. You gotta shut up, dude. You gotta shut up. He couldn't possibly have gone to the bathroom again, gone potty again, because he just went. Arch, we're doing Arch Linux, so that's Arch status. Let's see what that says. Cat Arch status. Okay. Mount S, Mount info, memory. What's in memory? Okay. I can't access this because I have to be sudo. So what I did that? Sudo cat mem. Okay, so again, so these are processes. I'm not going to try to explain it all, but here's the thing. Okay, all right. here's the issue with this. You know how everything has a process ID? Like, for example, if I open up, let's open up a new tab here. If I do PS aux, here are all the processes running on the computer right now. And it starts with one, which is init. Init is the first process that runs when the computer turns on. And then init runs every other process. Init is the core system running. And each process has an ID. See, PID? Right there, PID. And init is always PID number 1. If you kill ID number 1, you turn off the computer. That's what that is. Okay. In fact, if the computer's smart and you try to turn off PID number 1, you know, it might say, "Are you dumb? Grow up." It might tell you to go do something. So it goes down. We've got about 2, 6, 3, 5, 7 processes. Okay. Well, if you look here, well, here we got a process 9,000. Okay, no, 26,000. Okay. So we got 23,000. Do you have 26,000? Here, 26,000. See, 26,000. 313. Okay. So each of these has its own. It has all of this information about that process stored in its file, in that folder. Okay. Where does all this information come from? Where does this come from? It's stored in the folder 24668. Well, apparently it's not running anymore. What about 69? Well, apparently that's not running anymore. Jake, no! I may have to go run and deal with him. He may get too cantankerous. Okay, so when you turn the computer off, all these go empty. When you turn off the computer, all these are empty. They all stop. Every one of them. Okay. And you can do settings for every process, every little baby computer program that's running in your system. Okay. That's process folders. All of these, if I do this, htop, look at all the processes running. These are all, like Chrome is dominating everything because we're using Chrome. This is Chrome here. Okay. There, if we go down there should be a Vivaldi somewhere. An Epiphany. Oh, Epiphany. I'm using Epiphany to watch our live stream. There's our live stream. Okay. Here, let me turn off the live stream. We don't need it. So if I do that, watch. Epiphany should close. Okay, see, there's Epiphany. 22098. Let me close that. Okay, Epiphany's all gone. OBS, a lot of OBS processes. Here's OBS right here. I'm using OBS. Okay. All those are OBS processes. All these little programs running are stored in the PROC directory process. Okay. Yeah, I'm going to press F10 and get out of here. I don't think I need this, so I'm going to move that over there for now. Let's just look. Jake. Okay, it's... It's looking at each of these directories here. Okay. So, Jake, you gotta wait, dude. So the size of these. So the var directory has 18 gigabytes in it right there. That has SQL in it, the MySQL stuff. The user directory. That's where the actual logged in user will use and run things. This is where programs get installed to. Okay. So I'm a user. So for example, OBS is a program that's used by a user. It's not used by the system, it's used by a human. It's used by a user. So when you install OBS, it will put it in the user directory because it's where you install programs for users to use. Okay? Oh dear. Okay. I typed a search and it started searching infinitely for X. So the user library. If I install OBS, there's a lot of stuff OBS uses that a lot of other programs also use. So it will just install those things to the library, to the lib, for the library, and then if another program needs it, you don't have to install that part again. And that's how Linux, that's how it wants to work. It doesn't take every little thing you do for each program and reinstall it all over again. If Chrome and Vivaldi, Epiphany, let's say OBS, if all of them are using some libraries and some files that are the same, it will only install them once and put them in the library for everyone to use, for the other programs to use. Okay, but it's kept in the user directory, right here in the user directory, because that's where you install programs that are meant to be used by human users like me. Okay, that's what that is. All right, are you following this at all, Roy? Is this making any sense?
Yeah.
Okay. So that's the user directory. And if you look at this, the var and user directory are the biggest. Look at home. Look how big home is. 874 gigs. I've almost got a terabyte in there. Do you know what most of that is? English lesson videos. That's what most of it is. Because these English lessons, I record them because I want to be able to do research with them later. I want to be able to show and prove the progress that students have. So my home is very big because I do a lot of that work. OPT. Let's go into OPT. OPT is where we put stuff that does not follow the standard file system hierarchical standard. Okay, so your personal configuration files go in home. ETC is editable text configuration. ETC. Let's go in there quick. This is where the programs like a web server or an SQL database. Okay, if I'm making a server for a cloud to run games on, okay, those programs aren't used by a human user like me. Those programs are there for another computer program to log in and use. Okay. So, these have their own settings. So a lot of the system settings are kept in ETC. Now, it originally meant etc. Okay, but they backronymed it. They changed the name looking back for editable text configuration, which makes a lot of sense. Because you go in, the only way to change the settings for these programs for a server, like you set up a server to play, like a game server is a big example. It's a great example. Okay. You have a server, but it's not for humans to come in. Maybe it's serving a website. Okay, maybe it's serving a website. But the system files, not the programs for a human, which are kept in the home, but the files that are served or use as part of the system, their settings are kept in the etc directory. So if you set up a web server on Linux, you will have to go into etc to change things. Okay, that's, so Nginx, for example, is one of the web servers. So if I go here, I have some settings for that. If I go in here, okay, these are, I can use this to teach you how to develop websites, and we run the website on this local computer. The configuration to set that up is in here. It's in etc. Somewhere. HTTPD is the name of the program. So AppArmor, it's a security thing. Configs. Here's the thing about this. You'll see a lot of .d. Okay. Pacman.conf. That's a configuration file for Pacman, which is the package manager. That's what installs and removes software. Pacman.conf has its own configuration. Let's look at it. Look at that. It doesn't have anything. Probably using default settings. Let's say that I want many Pacman configs. I have many files for different things. If Pacman does this, I want to use that configuration. If it does that, we'll use a different configuration file. Okay? So, for different purposes, I have different config files for Pacman. Okay? Are you following me here? Now, normally, if I have a config file for Pacman, it'd be pacman.conf or pacman.cnf, something like that. Okay? But if I want many, for some reason, I'm using many files, I will put all of them in the same name but .d, which means it's a directory of many of these files. Okay, so let's go here. Wait. There. Now, here I am in the pacman.d directory. I have more files that I will use. I'll have many config files that are used for that, not just one. Okay. Okay. My.cnf, that's for my SQL. If I'm going to be complicated and I want many config files, I'll put them in a my.cnf.d directory. It's a directory that has many files for their part of the config. Are you following me? Do you understand what .d means? Rather than just one file for all this stuff, we'll use many files for our configuration and put it in a .d directory. Okay. So you'll see a lot of .d stuff. Conf.d, grub.d, pacman.d. Okay. Right. Now, there's a different convention, which is to name things, to put a D at the end of the name, which is another thing. Adding a D means daemon. It means it's a service that's always running. That's different. .d means I don't just want one file to do it. I want a whole directory with many files to do the job. That's all that means. Okay. But that needs a dot. If I don't do the dot, if I did pamd, like here IMAP D, because map, ID map, and then a D at the end, that means daemon, which means it's running as a service. HTTP, that's website stuff, right? HTTPD means daemon, which means it's a service it's running. It's like a mailman. So sometimes you'll see a D added to names. Look at this. FWUP. Okay? The D at the end means daemon. It's a service that's always running. System D. See? The D at the end means it's a service that's always running. It's the system service. Syscontrol.d, well, syscontrol means the settings to manage the system. D means we have a directory with many files in there for the configs. So adding a D to a name and adding a .d mean different things. .d just means we made a directory to handle many files for the job of one file. But that just is so much. There's so many files. This is the editable text configuration. Okay, that will be your configuration stuff for services. Now lib used to be its own directory, but now it's actually a link to the user directory. So it's actually user lib. It actually goes here. And bin like commands, like if I type ls, like when I type ls right here, that's a command. It's not run by another program. It's run by a human user like me. So that's actually a file in here. Most of my commands are in the user lib directory. CP, copy. In fact, almost every command. All the commands are in here. Gedit is in here somewhere. When you install a program, you have to put a command in this folder. I'm looking for Gedit. All right, get it right there. There's the command to run our favorite little editor, Gedit. To run this, that command is right there in user bin. These are the commands. Every command I'd type in here, everything I'd type in here, has to be a file somewhere in user bin. In user bin. Bin for binaries. Binary files. Here. All right. SBin is system. That means you don't want to touch that. It might be in, yeah. Boot is when you first turn the computer on, and that's where the Linux image is when it's just getting started. One of the very first processes it runs. It looks inside boot. SBin is, those are commands, programs only used by the system that no human should ever be typing. You want to stay out of that. Okay. OPT is for programs that don't follow this. These different folders use the things that we talked about. So, like services that run in the background, like for a server, their settings go in etc. Devices, your mouse, that'll be in devices. var is really for databases. Serve is for servers, and that's where websites should really go. Well, actually, var means change, variable or vary. It can change. Not V-E-R-Y, V-A-R-Y. For some reason, people are putting websites in the variable directory. The database is always changing, but websites should not be changing. So I put my website stuff in the serve directory because it's for a server. I don't put it in variable. But, Ubuntu wants to put web servers in the variable directory, which I don't understand. I don't get that. If you're not following these, for web developers, for software developers, okay, web or otherwise, that don't follow this, the OPT directory is for those. Microsoft, they don't know how Linux works, so they put all their stuff in their own OPT folder, optional. Dropbox just makes their own program work. They don't follow this. So they just put all their stuff in OPT and Dropbox. Google, for Google Chrome or Google Earth, they don't install stuff where it should go. They make their programs for Windows. Zoom, Vivaldi, Spotify, Microsoft, what's this? Microsoft Edge. Okay. OPT, the OPT folder is for programs that don't follow this file system hierarchy structure, the FHS. Okay. They write the program and they don't worry about trying to put these files in that folder and those files in this other folder. They don't try to follow that. So just you're going to write your own program. You don't know how Linux works and where to put things in Linux. Just you're writing your own little program. You're making your own rules. Okay. Put it in the OPT folder and just it's all by itself. Okay. My goodness, both of us are yawning. Stop it. Okay, all right. I understand this is boring. Okay, I'm making myself yawn. It's so boring. And that's a really yawn. Okay, so Roy, do you get the basic picture? There are these folders. There are these core folders that are used in Linux that are part of the structure. Mount, if you put in a USB and you open up the USB in the files, it will put it in the mount directory, MNT. Okay. It will see the USB drive in devices, but then it will put the disk at MNT, so you can go there. It's a place, it's a location you can type in the terminal to go get it, so it can access the files at a place. Media, that's like a CD. It's like a CD. It really is kind of redundant. You don't see a media directory in here. Now they just put it all in devices. SRV, that's for served files. Oh, email should go in server, in the served directory, if you're running a mail server. I think that the web server should go in the served directory. But a lot of people put in the variable directory. When you have a program that's running and it's always changing its own files, those files that are always changing, like part of it working, it just has config files that never change. Those will go in editable text configuration. It has libraries, just like someone already wrote a big program and I'm just going to use that and then I'm going to add some stuff to make it work. Well, that other stuff, anybody could use that. It's a library. It's someone else's library. We'll put that in the user user library. We'll put that in the library. But maybe there's another part of it that's always changing and always working, always changing, just always changing the files as part of it running. Those will go in the var directory. Maybe games. Okay, mail. Mail's always changing. I don't know why they want to put web folders, web directory, like website stuff in var. It doesn't make sense to me. The website shouldn't be changing. The website you're serving to the world, that should go in the served directory. That's what I think. Okay, so we looked at processes and we looked at run. Run is another one. I don't see. Oh, run here. These are things that are running. It's not processes is specifically by number, but things that are running are like there will be. It's almost like a RAM file, kind of. It's another part of the regular running. It's I don't know how to explain it. Usually var are real files that stay there, but you always change them as the program is running. You turn off the computer, it keeps it and picks up where it left off. Run, when you turn the computer off, in theory, this folder gets completely empty. It's like it writes down what it's doing now so that other programs can understand it. That's really what that's all about. So, you could learn the difference. I do not expect you to remember everything I'm telling you, but Linux at the root has different folders that are used for different things. And when people write programs for Linux, they need to know what to put in different folders. Oh, you're running one of those? Well, that file needs to go in this folder here. You go put it in var, and then you call it, mail or something. Okay. db sudo. Put it in the var directory and call it the name of your program. Call it Roy's program and put it in var if it's always changing. If it's running right now, put it in run and call it Roy's program.pd or something. And it will turn on, it will delete when you turn the computer off. Okay, it's like a mail program. Put it in the srv directory and call it Roy's mail. Okay, and put it in serve. And then the command to run it, put that in the user bin folder. Call it Roy's mail and put it in, and that's the command you type to make it work. Okay. So that's, you want to change the settings forever so that everyone has the same settings. We'll put a file in etc and call it Roy's mail.cnf or .conf, and put your settings for it in there. Let people change it in there if they want to. You're supposed to know your way around this as part of running Linux software, okay? So like for example, if you have an app, etc will have this file here for myapp.conf. It will say the socket is located in run. So when it's running, it will make a little fake virtual file, a pseudo file, and it'll put it here, which will have some information about the file while it's running. It's a fake file that's located in run, my app or something. And when you turn the computer off, this file will disappear. When you turn the computer back on and the program runs again, it'll recreate that fake file so other apps can see and talk to it maybe. Okay. Okay, so that's it. There is a temp directory. There's a TMP. Supposedly these all get deleted, but you don't really need to go there. It deletes stuff itself. Maybe when you download something, the file goes here until it's finished, and then it copies into your home. Okay. That's it. That's it. That's it. Next is logic. This is where the programming really gets fun, Roy. And if you study this stuff, then you will begin to understand the basics of computer programming. So, we could think about that. You're taking August off. We might just quit writing, Roy. We might. It's up to you. And just do these computer lessons if you want to take a break for the summer. You're welcome to do that. And learn some of these. And then computer programming will be easier for you to study in the future if you want to do that. Okay? There we go. Yay. Hip hip hooray. Yeah. I think we're done. Here.
Cody Couple.
Wow. So all done. And
This event is sponsored by my lava lamp.
okay, yes. I don't have a lava lamp, but I think I should get one. All right, Roy, do you have any other questions? I mean, you know, this is a nice, easy, fun day. You know what? Here's the thing. When I'm writing my own software, knowing these, most people who are software developers don't understand what these are. They don't know anything about this at all. No one ever told them anything. If you've at least known this, then you see those folders, you go, oh, those. Yeah. Those are all used for something. Hey Siri, what's that used for? You know, and Siri is stupid, so Siri might not know, but Grok will probably know. Okay. All right, Roy, I think we're done. See you next week. You can type something or just not, and we'll just continue, man. We can continue on with computer stuff. Bye-bye.
I just